This video will give you an introduction of within subjects designs. Within subjects designs are designs where each participant is tested under multiple conditions. So each level of your independent variable, where your independent variable is what establishes the groups that are being compared when you're doing mean comparisons in ANOVA. But within subjects designs is that every single participant is in every single level of that independent variable. And this is what the equation looks like for this type of model. Very similar to the between subjects designs, but slightly different based on the variances that are being used. These within subjects designs are also called correlated error models, but the one that you would most likely hear is repeated measures designs, or this is can also sometimes be called longitudinal ANOVA. So this goes by several different names. But regardless of the name, the biggest point is that every participant is in every level of your independent variables. So each participant is in each group. So now your ANOVA is more like a paired sample t-test than an independent sample t-test. So for the between subjects designs, you have independent groups where the participants in each group are only in one group. Whereas with now the within subjects design, it's like a paired sample t-test where we use paired sample t-test for like a pre-test, post-test comparison. And this is where every participant is in both groups. It's both in the pretest and in the post-test. But now we have 3 or more of these groups to be able to do this within subjects designs ANOVA. And so the subjects are providing multiple values for the dependent variable. And so for each level of the independent variable, each participant will have a value for the dependent variable. So the means of the dependent variable are still what's being compared across the groups, just as in any other ANOVA design. But now you have each participant is at every level of the independent variable. And so this repetition can be over time, and most often we see it over time. So it's 3 or more time points where each participant has a value of the dependent variable at each of those time points, but it could also be over treatments where it's like a leveling or a stacking of treatments, or it could be something where it's the increase of sessions, so the number of sessions, but you are measuring the dependent variable at each session. So then session 1 dependent variable value could be compared to session 3 dependent value and look and see if there's mean differences across all these different treatment levels. So within subjects or repeated measure designs are very useful, but you have to be aware that the error term is very different than when you are dealing with between subjects designs. So with between subjects designs, the within sum of squares is your error term. But now you have a different kind of error term that needs to be calculated for these within subject designs. And so that has to be taken into consideration, but it makes it so you can have fewer subjects or participants. You can have smaller groups because your degrees of freedom is based on subjects times observations, where observations equals your number of levels. So it's number of your independent variable levels And so at each one of those levels, each participant is giving a unique value of the dependent variable. And so they're counting as one within the sample size instead of one person. So they're one at each level. So if an independent variable has 3 levels, and you have a participant that's in all 3 of those levels providing a unique dependent variable value for each of those 3 levels, now your sample size is actually 3 and not just 1. So within subjects designs have some significant pros. So one is that it's really good when you have a limited size on your population or on the sample that you can obtain from that population, because you are having each participant provide a unique value for the dependent variable at every single level of your independent variable. You need a smaller number of participants, but you still can have an ample sample size for conducting your analyses. Also, it's very helpful when your subjects or your participants are hard to recruit, or if there's some kind of risk, whether it's dangerous or it's boring, whatever that risk is, can be counterbalanced with using this type of design, again, because you don't have to have as big of a sample size to be able to complete this model and these analysis. Can save a lot of time in doing data collection and building your sample. You also can use this model to learn about learning and practice and transfer, where you can see how the values of your dependent variable change over time by comparing each individual essentially to themselves and being able to see how that trajectory is changing. So now you're actually able to map learning and practice and transfer of information. It also reduces the error variance because now you are reducing that sample size and you're reducing the possibility of error variance being introduced, especially because with the within subjects designs, there's a different error calculation than with the between subjects designs. And it's more about the pattern differences between individuals over time or over the levels of the independent variable than it is about the differences within each group. But of course, with all statistical models, there are some cons and some things that we have to keep in mind. And so for within subjects designs, they can be more restrictive in their assumptions because you don't have a randomized design where you do have all participants being in every single level of your independent variable. And so you do not have independence across your groups that are being compared. And so this can make it more stringent in trying to identify statistical significance and also make it a little bit more complex in interpreting the results. You could also have problems with practice effects, where if each level of the independent variable is dependent on the level prior. So if it's where each level of your independent variable is looking at different number of sessions or different amount of exposure to a particular treatment, now each level is going to be dependent on the level before. So whatever their exposure was at the first level, the first time that you are measuring the dependent variable, that's going to be within each one of the measurements later on. And so you get this kind of practice effect where the level prior is going to be impacting these new levels. Also, it's The sensitivity of the design is a little bit different than between subjects designs, and it tends to reduce um, that practice effect. But when you have those practice effects there, that is going to impact the sensitivity, and sensitivity has everything to do with the amount of or the probability of having a type 1 error. And so practice effects and sensitivity impact each other, which can impact the error. And we already know that within subjects designs have very specific error calculations. And also you have to use counterbalancing to be able to account for this lack of independence across the groups and the potential of having these practice effects. So some unique characteristics of repeated measures or within subject designs is that there is no within term. Because you have every participant at every level, there isn't a within term because each cell is one individual. And so there's no comparison between that individual. There's a comparison between that individual and themselves at each level of the independent variable. But within each one of those levels, there is no way to compare within those groups because your within value is each individual. Also, you actually have some pretty good increase in efficacy, but this also increases the complexity of these repeated measure models. So you can get some really good information about the trends that you're seeing across the levels of the independent variable. Um, but because you have these error terms that have to be calculated in a different way, it can bring some complexity to the expected mean squares calculation. And this can add to some issues with um, being able to interpret and look at the effect sizes or practical significance of these types of models. Also, what a lot of people really like about these repeated measures or within subjects models is that each of your subjects or participants is really being compared to themselves. And so you have perfect matching. And so you don't have to worry about if your different groups are balanced as far as other demographics or other characteristics that may not be included in the model. And so other characteristics and other demographics could impact your overall results for your ANOVA, but within subjects models are comparing each subject or participant to themselves at each level of the independent variable. And so this makes all of those groups very balanced. And so repeated measures designs are considered to be balanced.